So here you can see you have to solve this question, table 1. Question number 1, the table shows some information about alkanes. Methane, its formula is given, its boiling point is, yes.
The screen is still loading.
Okay. So I think there is some problem in your network issue.
Yes, I spent about 5 minutes trying to join the lesson.
Now is it visible?
No, let me try and look where the Wi-Fi is working a little bit better.
So you can do one thing, you can just leave the session and then again join.
Yes, ma'am.
Am I audible now? Is my screen visible?
Yes.
Okay. So you have to solve this question that the table shows some information about alkane. This is your methane, its formula is given and its boiling point is given. So you have to tell me what should come here, right? And what should come here. So the question is, first part, that name the alkane with the formula C2H6. What is the alkane with the formula C2H6? It is?
It is.
Yes. Now what's the molecular formula of propane?
C3H8.
Yes. Now what should be the boiling point of C2H6?
I don't know, ma'am.
So what you have to remember here, that as the number of carbon atom increases, your boiling point also increases. So it should be between minus 162 and minus 42. As the number of carbon atom increases, boiling point also increases. Okay.
So you can write any number between minus
Yes.
62 and minus
Yes.
52. Okay.
It should not be like minus 152 or minus 50. It should be in the middle range. Okay, like minus 100. It is in the middle of these. Okay.
Yes, ma'am. Yes.
Next is, yes. If we write, the question is that state two types of reactions which alkanes show. So I have told you in the yesterday's session, in the last session, that two types of alkanes are generally unreactive, but they show only two types of reaction. One is combustion and one is substitution with chlorine. Okay.
Yes, ma'am.
Yes.
What if I just say substitution? Is it wrong if I don't write with chlorine?
No, you have to write substitution with chlorine because alkanes generally show the reaction with chlorine. Okay, it does not show easily the reaction with bromine and iodine. It shows substitution reaction with chlorine only.
Yes, ma'am.
Next question is copy and complete this equation for the reaction of C2H6 with oxygen. C2H6 reacts with oxygen. It forms what? Only two products, carbon dioxide and water. Then you have to just balance the equation, and I hope you know how to balance the equation. Okay. So whenever there is a combustion of alkane, the products are always carbon dioxide and water. Clear?
Combustion always produces carbon dioxide and water.
Yes. Carbon dioxide and water.
Yes, ma'am.
Write down this. The important points which you want to write.
Yes, ma'am.
Hello, Silathemba. Welcome to the session. How are you? Am I audible? Okay, so we are discussing the organic chemistry chapter in which we have discussed the alkanes in the last session. Now we are going to discuss some questions here. Okay, so let us now discuss about the. Okay, very good. Now these are some questions which you have to solve, and please try to join the sessions on time. Okay. So question number 1 is that alkanes react with chlorine. State the essential conditions for this reaction. Okay. So alkanes, that means your ethane, methane, propane, they react with chlorine. So essential condition is ultraviolet light. There should be UV light present for the alkanes to do the substitution reaction with chlorine. So it is a 1-marker question. You have to write ultraviolet light. Question number 2 is construct the equation for the reaction of one molecule of CH3CH3. It is what? Ethane, right? So you have to write down this equation with one molecule of chlorine. So what happens? One H of this is my CH3 and this is my CH3. So here one hydrogen, it gets replaced by one chlorine. Okay, and then we have the product. The reaction happens minus HCl, and here we have the product like this: CH3 and CH2Cl. Okay, so here the product is CH3CH2Cl plus HCl. So this is a question of 2 mark. Is it clear? Any doubt in these two questions? Is it clear? Whenever you are done writing Silathimba, please write down in the chat, okay, or react it with a thumbs up.
Sorry, ma'am, I was having some network problems. Ma'am, I have a question. So, do you always take one hydrogen and chlorine during a substitution reaction, like in every single scenario?
What? Please repeat.
I'm saying, in this case, right, we took one hydrogen, right,
Yes.
from the first reactant, and then we took one chlorine, and then we formed
Yes.
hydrochloric acid. So, do we
Yes.
always do this in form of every single substitution reaction, whether
Yes.
the
In
first
every single
element, I mean,
substitution reaction of chlorine, your HCl is removed. From the alkane, hydrogen is removed, and from the Cl chlorine, your chlorine is removed. You are asking that if you want to remove this hydrogen or this hydrogen, right?
yes.
Since
Thank
it
you,
is
ma'am.
symmetrical, yes, it is symmetrical, so you can remove any of the hydrogens.
Yes, ma'am. Let me write it down.
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done, ma'am.
These are your homework questions. You have to write down the word equation for the combustion of butane. Question number 1. So for the combustion, I already told you that in combustion, your alkane react with oxygen and the products are always carbon dioxide and what?
And water.
Water. Very good. Question number 2 says chlorine reacts with ethane in the presence of light. Describe the type of reaction that occurs. Okay. So which type of reaction is occurring here?
A photochemical reaction.
No. Substitution by chlorine.
So you said. No, ma'am, I thought you're talking about the part where there's the presence of light.
Yeah. Yes, it is okay. Chlorine reacts with ethane in the presence of light. Basically, the mechanism is substitution. Here we have studied. See. See this point? Alkanes reacts with chlorine in the presence of ultraviolet light and chlorine by a substitution reaction. So the name of the reaction is substitution reaction by chlorine. In photochemical reaction, it depends on the presence of light. Okay, it doesn't written here UV light. Okay, which provides activation energy. So it may be any reaction, not a particular chlorine reaction. But in this question, it is asked in the chlorine reaction in the presence of light. Okay, so it is substitution by chlorine.
Yes, ma'am.
The exact answer is this. Otherwise, you can write photochemical reaction also because light is providing the activation energy here.
Yes.
Write it down. Your homework question.
I'm done, ma'am.
Next is your cracking alkanes. So this topic is also very important. Cracking alkanes. That means you are breaking the long chain alkanes into the shorter chain alkanes. So what is cracking? It is very important. It is the breakdown of long chain alkanes into shorter chain alkanes and alkenes also. So this is the definition of cracking. It is carried out because why it is done? Because we need shorter chain alkanes and alkenes then can be supplied by the distillation of petroleum. Because in some processes we need shorter chain alkanes. That's why we use this cracking. Hydrogen, it can be produced by cracking shorter chain alkanes. If you crack shorter chain alkanes, then hydrogen is produced. So your long chain alkanes is cracked to produce shorter chain alkanes, alkenes, and hydrogen. What are the conditions for cracking? High temperature is needed and a catalyst is needed. So these are your 5 points of cracking which are very important. The definition, why we are doing this cracking process, okay, and what are the products which form after the cracking of long chain alkenes, and the conditions for cracking, high temperature and a catalyst. Okay. Clear?
Yes, ma'am. Ma'am,
Yes.
remember when we were doing that topic, I think it was reversible reactions, right? And
Which
then
reaction?
you said,
She left.
when we're doing the topic on reversible reactions, you say something about cracking as well. What were we cracking?
You are not properly audible. Please speak again.
I said when we're doing the topic on, I think, reversible reactions, we were talking
Reversible
about
reaction.
where we get, yes, we're
Mhm.
talking about where we get like, there was oxygen, and then there was hydrogen. There was something else that needed to be cracked. I forgot
In
what it
reversible
was.
reactions. Reversible reaction of which
Yes.
type? Like we have many reversible reaction. Haber process is also a reversible. Contact process is also reversible. So in which process you are talking about? Because every reaction
I
is
think it was
different.
the Haber. I think it was the Haber process.
It was for Haber process.
Yes.
What is Haber process?
In the Haber process, there's
Formation of ammonia, right?
ammonia. Yes.
Yes. So there are some conditions which are needed. There we need high pressure condition. Okay, the temperature should be moderate, and you use a catalyst. Which was the catalyst? What is the name of the catalyst?
Vanadium 5 oxide. No, iron.
Yes, iron is the catalyst. So these three conditions are required for your Haber process. There's no condition of oxygen as you are saying. That is in the
No,
yes.
oh, it's in the. Sorry, ma'am. You can continue.
Okay. If you have any doubt because you are not properly audible, write it in the chat box. I'll surely answer. Okay.
Oh no, ma'am. You have answered my question.
So please write it down, and once you are done, please let me know.
I'm done, ma'am.
Okay. Next question is hydrocarbons are cracked in an oil refinery. Explain the meaning of the term cracking and explain why it is carried out. So you can easily answer this question. Okay, so write this. State the conditions need for cracking. You know the conditions are high temperature and catalyst. Dodecane, that is your C12H26, is cracked to produce an alkane and one other hydrocarbon. Write the molecular formula for hydrocarbon. So you know that when C8, you just have to subtract C12H26 minus C8H18, you get your S. Question number 4 is ethane can be cracked to produce a hydrocarbon and one other gas. So what is the gas here? Hydrogen. And ethane converted into an alkene, it is ethane. So these are your 4 questions which are based on cracking. Write this all the 4 questions on in your notebook, and if you have any doubt in these 4 questions, then please do let me know.
Ma'am,
Hmm.
what is the difference between petrol and petroleum?
What is the difference between petrol and
Petrol and
petroleum?
petroleum. Yes.
Okay. So in petroleum, petroleum is the combination of all the other fractions, in which petrol is your one fraction. Okay, petrol, it is also known as your gasoline. We have discussed the fractional distillation of petroleum, if you remember. So it is a derivative of petroleum. It is not the petrol. So you have a category of petroleum, which we have studied the fractional distillation. Okay. When we do the fractional distillation of petroleum, your one of the fraction is petrol, which is also known as gasoline. So petroleum, it is a raw unprocessed mixture of hydrocarbons which are found in the underground, and it is a refined product. Okay, after refining, we get this product. So it is a refined product which is used as a fuel. Okay.
Yes, ma'am. I'm done, ma'am.
Yeah. Next is your alkenes. Alkenes is what? Unsaturated hydrocarbons. Unsaturated hydrocarbons, they contain carbon-carbon double bond or carbon triple bond carbon. Okay. Saturated means you have only single bond of carbon. So they are unsaturated hydrocarbons. What is alkene? Unsaturated hydrocarbons because one or more of their bonds are carbon-carbon double bonds. Okay. Their distinguishing test is that they turn aqueous bromine from orange to colorless. First of you know what is the color of bromine? Its color is, okay, I will go to the previous one after explaining this alkenes part. So, unsaturated hydrocarbons, it turns aqueous bromine from orange to colorless when the hydrocarbon is in excess. So, you get to know if the bromine turns from orange to colorless, you know that there is an alkene present here. Then alkenes react with steam to form alcohols. Conditions, you have to remember all the conditions. 300 degrees Celsius temperature, 6000 kilopascal pressure, and an acid catalyst whenever an alkene reacts with steam to form alcohol. What is an addition reaction? As the name suggests, two or more compounds react to form only one product. Okay. Addition reactions of alkenes include reaction with bromine, steam, or hydrogen. We will study these reactions. Hydrogen react with alkenes in the presence of nickel catalyst to produce alkanes. For example, if this is my alkene, which is your ethene, right?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So when hydrogen reacts, H2 reacts with this alkene in the presence of nickel as a catalyst. So you get a pure alkane. Hydrogen will attach here and a double bond is converted to single bond. So this is also a very important reaction. Okay, so Silathema, please write this slide first. If you have any doubt from this slide, then please do let me know. After that, I will go back to the previous. Okay, first of all, write this one.
Ma'am, you said there's need for an acid catalyst. Isn't it nickel is not an acid?
Nickel is a metal, D block metal, not an acid catalyst.
I'm done, ma'am.
Okay, so please write this one. What is left? Yes, Amma. Done? Okay.